Morning, students. Can you see the board now?
Yes, sir.
Can you see the board now or not?
Yes, sir. We are able to see.
Okay. Thank you. So okay, now I'm going to solve some more problems in higher order PDE. So today is the last class for Unit 1 and also for higher order PDE. So from Monday onwards, I will start the Unit number 2, Fourier transform. Okay, so before that, this is the first column today. So d square plus 3d dash plus 2d dash square into z equal to x plus y. So the right hand side function is polynomial in x and y, and hence it is type number 3. So the auxiliary equation is m square plus 3m plus 2. The roots are 2 and 1. The roots are minus 1 and minus 2, and the roots are distinct. And hence the complementary function is phi 1 of y minus x and phi 2 of y minus 2x. So if you have any doubt, you can ask me. So I am going a little bit fast because this is the third class in higher order PDE. And the particular integral is equal to 1 by d square plus 3d dash plus 2d dash square of x plus y. So you should write the denominator in the form of 1 plus x or 1 minus x. That's why I take commonly d square. So if you take commonly d square, here remaining 1 plus 3d dash plus 2d dash square divided by d square. Now, so I'm going to write this 1 plus x in the numerator, that is 1 plus x whole power minus 1. Okay, 1 plus x whole power minus 1, and then you know the formula for 1 plus x whole power minus 1, 1 minus x plus x square, and so on. Okay, so before that, I'm simplifying this part, the x part. So 3d d dash by d square is what? After cancelling d and d, 3d dash by d, and then 2d dash square by d square. Okay, there is nothing common, so 2d dash square by d square whole power minus 1. So in the next step, you can expand it. So 1 minus, this is x, and then plus x square, and then minus x cube, and so on. But the series is the expansion of the series is depending upon the powers of y. The power of y is 1 here. Why it is depending upon the power of y means because the numerator will have d dash. D dash is dou by dou y. So that's why it's depending upon the power of y. So y is power 1, and hence up to the first term is enough. That is 1 minus x power 1. Up to that term is enough. So even though it is enough for up to this term, I will write one more term. So if you see here, a square, because here this is a plus b whole square formula, a square term will contain d dash square. So d dash square of x plus y is 0. Similarly, b square term contains d dash power 4. The 2ab term contains d dash into d dash square is d dash cube. So that's why I don't need this term. So I will write only the first term 1 minus x term. So 3d dash by d plus 2d dash square by d square of x plus y. Now 1 into x plus y. So x plus y minus 3 by d d dash of x plus y. And if you differentiate 2 times d dash square means you should differentiate 2 times with respect to y. So this is 0. Okay. Now from here to here, 1 by d square x plus y, 3 by d. D dash means dou by dou y. Dou by dou y of x is 0. Dou by dou y of y is 1. So now I am going to operate 1 by d square in each and every term. So 1 by d square of x plus 1 by d square of y minus 3 by d cube of 1. So that is 3. Okay. If you integrate 2 times, okay, 1 by 1 will do it. Okay, 1 by d of, if you integrate first time, we'll get what? X square by 2. And if you integrate the first time, we'll get y into x. Similarly, if you integrate first time, you'll get 3 by d square into x. If you again integrate it, you'll get x cube by 6. Here, y into x square by 2. Here, minus 3 into x square by 2. So this term, and then only thing I need to integrate this. So integration of x square is x cube by 3. So 3 gets cancelled. So x square y by 2, this term is here, x cube by 6, and x cube by 2. So to take LCM, and if you simplify, you will get the answer. So this is the particular integral part, and the general solution is sum of complementary function and the particular integral. Okay. So this is one of the problem. Yesterday I gave a homework, not homework, it is a practice problem. I gave 4 problems. I think this is the first problem. X plus y square plus pi, right hand side. So pi is also constant. So you should take everything is a polynomial in x and y. So it comes under type number 3. Okay, so the auxiliary equation is m square plus 4m minus 5 equal to 0. So if you factorize, you'll get m plus 5 into m minus 1. Okay, the roots are 1 and minus 5. So it is distinct, and hence the complementary function is y plus x, phi 1 of y plus x, and phi 2 of y minus 5x. Okay, now particular integral. So if it is comes under type 3, you should write the denominator in the form of 1 plus x or 1 minus x. So I should take commonly d square. If I take commonly d square, 1 plus 4 d dash by d square means 4 d dash by d, and minus 5 d dash square by d square. Okay. Now I will write this term in the numerator, 1 plus x. So 1 plus x whole power minus 1 of x plus y square plus pi. So 1 minus x whole power minus 1 expansion. Okay, so again, the expansion is depending upon, okay, it's power of y. So power of y is 2. So that's why I'll write up to here, x square term. If it is y cube, I need to write one more term. Okay, so 1 by d square minus 1 minus x power 1 plus x square. Okay, now I need okay, before you can check it here. This is a minus b whole square formula. If you apply a minus b whole square formula, this is what first term is. First term contains d dash square. Okay, so d dash square I need because here I have y square. The second term b square, that is d dash power 4. So I don't need b square term. 2ab term contains d dash into d dash square, that is d dash cube. So that is also I don't need because here y square. So I need only from this the first term. The first term means a square term, that is 16 d dash square by d square. So that term itself enough for me. The remaining 2 terms I don't need. So that's why I'll write in the next page. Okay, 1 by d square, you can check it. 1 by d square, 1 minus 4d dash by d plus 5 d dash square by d square, and then plus 4, not 4, 16 d dash square by d square. into x plus y square plus pi. So collecting only terms up to d dash square in the numerator, as we have y square only in the operand. Okay. So 1 by d square. Now I am going to multiply each and every term to x plus y square plus pi. So 1 into x, we get x plus y square plus pi minus 4 by d. If you differentiate d dash of everything, that is d dash of x plus y square plus pi. So x plus pi is constant with respect to d dash. So you will get 2y plus 5 by d square. If you differentiate twice, you will get 2. First time 2y, second time 2. Similarly, 16 by d square, if you differentiate 2 times with respect to y, you will get 2. Okay, 1 by d square, x plus y square plus pi, minus 8 by d into y plus, okay, I think this is, the denominator is same for both the terms, d square, here 32 d square, 32 divided by d square, here 10 divided by d square, so totally 42 divided by d square. Now I am going to operate 1 by d square on each and every term. So 1 by d square of x and 1 by d square of y square plus x, because with respect to d, y and pi are constant. So that's why I'll group these two. Minus 8 by d cube of y plus 42 divided by d power 4. If you integrate 2 times, you get x cube by 2 into 3, 6. Okay, if you, this is constant. If you integrate first time, we'll get what? X. If you integrate second time, x square by 2. Similarly, 8y is constant with respect to d. So if you integrate 3 times, you'll get x cube by 3 factorial. Similarly, 42, 1 by d power 4 of constant. That is, you get x power 4 by 4 factorial is 24. So next to x, I think this is same. This is same. 8 by 6 is 4 by 3, and then 42 by 24 is 7 into 6, 42. 6 into 4, 42. Okay, 7 by 4 into x power 4. This is pi. So general solution is z equal to cf plus pi. Okay. So next, I am going to give you some of the problems in Lagrange's equation and some 2 problems in PDE. And then if time permits, I will give, I'll solve at least 1 or 2 problems again in higher order PDE. Okay, so this is a 2 more question. So geometrical representation of a singular solution of PDE. So sometimes they will ask in the examination. So that's why here I mentioned. So geometrically, the singular solution of a PDE represent the envelope of the family of surface represented by the complete solution of that PDE. So in the first semester itself, we studied evolutes and the envelope. Then the envelope definition itself, you may studied, okay, like this. So geometrical representation of singular solution of the PDE. So the first order PDE, we find the complete solution and the singular solution and general solution. So what do you mean by singular solution? What is the geometrical meaning of singular solution? So geometrical meaning of singular solution of PDE represent the envelope of the family of surfaces represented by the complete solution of that PDE. Okay. So this problem comes under Lagrange because this is the form PP plus QQ equal to R. So this is a little bit a different problem. That's why I want to explain this problem to you. Okay. So auxiliary equation. So dx by p equal to dy by q equal to dz by r. So each ratio here I am subtracting the first ratio minus second ratio here, numerator as well as denominator. Similarly here second ratio minus third ratio, numerator also and denominator also, and then third ratio minus first ratio. Okay. So, and then the numerator I am writing d of x minus y. The denominator I am writing x square minus y square is x plus y into x minus y. Here what is common? Z is common. So if you take Z commonly, remaining is what? X minus y. Similarly, here y square minus z square, y plus z into y minus z. So what is common here? X is common. If you take x commonly, y minus z, and here d of z minus x. So z square minus x square is, you can write z plus x into z minus x. And here y is common. If you take y commonly, remaining have z minus x. Okay. So here x minus y is common. So if you take x minus y is common, x plus y plus z. Similarly here y minus z is common. If you take y minus z, remaining have x plus y plus z. Here z minus x is common. So that's why it is x plus y plus z. So you can cancel x plus y plus z each and every term. You will get d of x minus y by x minus y equal to d of y minus z divided by y minus z equal to d of z minus x divided by z minus x. Okay, now consider the first two terms. If you consider the first two terms, you will get log of x. If you integrating this term, you will get log of x minus y equal to log of y minus z. Please write BV blah blah. Check. Okay. Check. Okay. So if you integrate log of x minus y equal to log of y minus z plus log a. So this you can write log of x minus y minus log of y minus z equal to log a. So and hence you can write log of x minus y by y minus z equal to log a, or x minus y by y minus z equal to a. So this is u of x comma y comma z. So I got the one solution. I need one more, but if you take these two, then you'll get a solution, but it is not linear. It is not independent with this solution. You'll get the solution obtained from these two ratios is a dependent solution with u. So that's why here there are some other technique we need to use. So take the multiplier z x y here. Okay, multiply the first ratio by z, second ratio by x, and third ratio by y, and add it. Similarly, denominator. If you do like this, the denominator is 0. You can check it. And if the denominator is 0, you should write the numerator equal to 0. You take this is equation 1. And similarly, you need to use multiplier y, z, and x, and perform similarly. You'll get another equation. If you add 1 and 2, z dx plus x dy is here, and x dy, y dx is here, and y dz and z dy is here. So you can write this one is a differentiation of x into z, this one is differentiation of x into y, this one is differentiation of y into z. If you integrate, you will get xz plus xy plus yz equal to some constant that is equal to b. So this is b of x comma y comma z. So the general solution is f of u comma v equal to 0. This is u, this is v. But I know that again, to find the multipliers is a little bit difficult, but this comes by practice only. It is okay, but just by seeing the problem, even I can't find the multipliers. But trial and error method only help, and practice. And also here, the problem itself, here you can write, just think about it. Here y z, here zx, here xy, and the x square, y square, z square are fixed. So we should analyze the given problem also. Okay, you should analyze the given problem, and this is little bit like a research. Okay. Okay. And one next problem. So this is also a little bit a different problem. That's why I want to explain this one. So d power 4 minus d dash power 4 into z equal to e power x plus y. E power x plus y. Okay. You can. This is another form of d and d dash. Okay. The auxiliary equation is m power 4 minus 1 equal to 0. So you can write this is m square whole square minus 1 square whole square equal to 0. This is our form a square minus b square. So a square minus b square is a plus b into a minus b equal to 0. So m square equal to 1 means m equal to plus or minus 1. M square equal to minus 1 means m equal to plus or minus I. Here all the roots are distinct. So plus 1, minus 1, plus I, minus I. So the complementary function is f1 of y plus x plus f2 of y minus x and f3 of y plus ix plus f4 of y minus ix. Okay, to find the pi, there are two methods here I am going to explain you. You can use any one of the method in the examination. First method is if you replace here, the right hand side is the exponential function e power ax plus by, so and hence this comes under type number 1. You need to replace d by a, and a is 1 here, and replace d dash by b, and b is 1 here. So if you replace like this, the denominator is equal to 0. So then you can write the denominator like the factors like this. Okay, because you know that 1, I'll write 1, minus 1, and I and minus I are the roots. So this implies m. Okay, m plus m minus 1 is a factor, m plus 1 is a factor, and m minus 1 is a factor, and d minus I is a factor, and d plus I is a factor. Sorry, everything m. Okay. So m minus I, m plus I. So instead of usually we will replace d by m. So d and d dash by 1. So d plus d dash and d minus d dash. You can check it, and then d minus I into d dash. Here d plus I into d dash. You can check here. So d minus d dash. Okay, and d plus d dash, and then d minus I into d dash. D minus I into d dash. So d plus I into d dash. Okay. Now you can combine these two terms. Okay. Okay. Before that, before combining this, there are 4 factors. Out of 4 factors, how many factors are going to 0 if you apply d equal to 1 and d dash equal to 1? So that is the question. Okay. So the only one term. Okay. This term only goes to 0 if you apply d equal to 1 and d dash equal to 1. So if there is only one term goes to 0, then we should multiply by x power 1 by 1 factorial. Suppose there are 2 terms are 0, then x square by 2 factorial. 3 terms means x cube by 3 factorial. 4 term means x power 4 by 4 factorial. So here only one term. So x power 1 by 1 factorial. Okay. For this factor, I will write x power 1 by 1 factorial. For this factor, 1 plus 1. 1 plus 1. If you combine these two, that is d plus I d dash into d minus I d dash is d square plus d dash square. Now apply d equal to 1 and d dash equal to 1, you will get this. That is 1 square plus 1 square. Okay, I think it is clear. If you have any doubt, you can ask to me. X by, this is 2, this is 2. So 4, 2 into 2, 4, x by 4 into e power x plus 1. So this is method 1. Method 2 is already you know that method 2. If you apply d equal to 1 and d dash equal to 1, the denominator is 0, then you should multiply the numerator by x and differentiate the denominator with respect to d. So then you get 4 d cube. This is 0. Okay, 4 d cube minus 0 into e power x plus 1. So 1 by d cube means you should integrate 3 times with respect to x. With respect to x, keep y is constant. So integration of e power x plus y, if you integrate any times, you'll get e power x only. Okay, so the final answer is x by 4 into e power x plus y. So the same thing. So x power 4 into e power x plus 1. Okay, so the final answer, general solution is z equal to CF plus PA. So the next problem, solve r minus 4t equal to sine of 2x plus y. So you should know what is r and you should know what is t. Okay, r is dou square z by dou x square and t is dou square z by dou y square equal to sine of 2x plus y. This is comes under type number 2. So before going to PI, first we will find the complementary function. So m square minus 4 equal to 0. So m equal to plus or minus 2. The roots are distinct. So f1 of y plus 2x and the f2 of y minus 2x. So to find the PI, you need to replace t square by minus a square. That is minus 2 square. That is minus 4. Similarly, d dash square is minus b square. That is minus 1 square is minus 1. And d dash is minus ab minus 2 into 1 minus 2. Okay, here there is no terms contains d dash, only d square and d dash square. So 1 by d square is what? Minus 4 minus 4 into d dash square is minus 1 the sine of 2x plus 1. Okay, now the denominator is minus 4 plus 4, 0. So you should multiply the numerator by x and here, from here. Okay, you should multiply the numerator by x and differentiate the denominator with respect to d. So you'll get a 2d of sine of 2x plus y, x by 2. So 1 by d means you should integrate with respect to x and keep y is constant. So if you integrate sine of 2x plus y, you will get minus cos of 2x plus y, and the coefficient of x is 2, you should divide by 2. So minus x by 4 into cos of 2x plus y. So finally, general solution is z equal to CF plus PA. Okay. So next problem, solve d square plus 2 d dash plus d dash square into z equal to 2 cos y minus x sin y. So again, this is comes under this is not type 1. You know that type 2 is also not okay. You have cos y and the x sin y. It is not it's not algebraic. It's not a polynomial. So type 4 should contain exponential. Type 6, both of them are sine or both of them are cos. So that's why it comes under type number 5. The last class itself, I solved one problem in type 5. So type 5 is a little bit different. So that's why I want to solve at least 1 or 2 problems more. Then only you can understand the concept. Okay, so auxiliary equation is m square plus 2m plus 1 equal to 0. So m plus 1 whole square equal to 0 implies m equal to minus 1 and minus 1. The roots are repeated here. The complementary function is phi 1 of y minus x plus x into phi 2 of y minus x. Okay. So in type number 5, so you should write the denominator, you should factorize like this. because d plus 1 whole square. Actually m plus 1 whole square. From this you can easily write what? Instead of d, you can replace m by d plus 1 by d dash. So d plus d dash whole square. Otherwise, from this you can write, okay, d plus d dash whole square. That is nothing but d plus d dash into d plus d dash. Okay. Now, the right hand side function is what? Right hand side you have 2 into cos y minus x into sin y. Okay. Now, yesterday I gave one formula. Okay. So, using the, suppose even if you forgot that formula, you can solve that problem. But I will write the formula, but not without using that formula also. How to you can do by shortcut, I will explain you. Okay, d minus md dash of f of x comma y, okay, is equal to integral f of x comma a minus mx into dx. After integrating, you should replace this a by y plus mx. So this is the result I gave. Suppose if you have here instead of minus, suppose if you have plus here, okay, then instead of if you have minus, here plus. Suppose here plus means here also plus, here minus. So that is the only change. Okay. Now, so you should write 1 by d plus d dash into 1 by d plus d dash of 2 cos y minus x sin y. Okay. Now you forgot the formula. Okay. So then what you need to do here, 2 into cos, instead of y, you should replace a plus x, a plus m into x. Here m is 1. So instead of d, you should put a, and instead of d dash, you should put some x. So a plus x, like this. It's a shortcut, but you should know. If you know the formula, you can write. Otherwise, you should remember like this. So instead of y, you should replace a plus m. M is 1, so a plus x. Okay. Similarly, minus x, you should keep x as it is, sine of y. So instead of again y, here a plus, I write m, but it is not m. Here it should be m equal to 1 into x. Into x. Okay. And finally, you should replace again a plus x is equal to y, or a equal to y minus x. Okay. So instead of a plus x, finally you should replace by y. So if you have any doubt here in this step, you can ask to me, because this is a crucial step in this problem, how to apply this formula. And once you understand this, the next step is integration. So here you have 2 into cos of a plus x. If you integrate cos of a plus x, you will get sine of a plus x. Here, integration with respect to x. Here also you have x, here also you have x. So you should apply Bernoulli's formula. So next step, 1 by d plus d dash. If you integrate this, you'll get what? 2 sine of a plus x. Okay, I write directly, minus x, integration x into sine of a plus x into dx. Okay, so there is nothing new here. So this is u, this is b. So keep u as it is. If you integrate sine of a plus x, you will get minus cos of a plus x, minus, if you differentiate x, you will get 1. If you integrate minus cos of a plus x, you will get minus sine of a plus x. Okay, so 1 by d plus d dash 2 sine of a plus x minus into minus plus x into cos of a plus x. Here minus, here minus, here minus. Totally 3 minus, so minus sine of a plus x. Okay, and then here again I need to replace a plus x by y. So x into cos y. This is 2 sine of a plus x minus sine of a plus x is sine of a plus x. Sine of a plus x is sine y. Okay. Now again you need to apply 1 by d plus d dash, the formula. So integration, you should keep x cos instead of y, a plus m is 1 into x plus sine instead of y, again a plus m is 1 into x. Okay, so you should replace finally a plus x by y or a equal to y minus x. Here you have two functions. So x, here cos of a plus x, Bernoulli's formula. So you keep x as it is. If you integrate cos of a plus x, you'll get sine of a plus x minus, if you differentiate x, you'll get 1. If you integrate sine of a plus x, you get minus cos of a plus x. And you need to integrate the sine of a plus x also. So if you integrate sine of a plus x, you get minus cos of a plus x. So if you simplify, you get there is no change in the first term. So minus into minus plus, so cos of a plus x minus cos of a plus x. So plus cos of a plus x minus cos of a plus x gets cancelled. You'll get x into sine of a plus x, but the a plus x is y. So final answer is x into sine y. So this is your pi. The general solution is CF plus PA. So next problem. So here also the right hand side is 16 log of x plus 2y. So this is comes under type number 5. Type number 5. So first CF complementary function is 4m square minus 4m plus 1 equal to 0. So you can write this is the form a minus b whole square formula. So 2m minus 1 whole square. So m equal to 2m equal to 1. So m equal to 1 by 2 and 1 by 2. The roots are repeated here. So the complementary function is phi 1 of y plus m is 1 by 2 into x plus x into phi 2 of y plus 1 by 2 into x. Okay. So if it is type 5, you should write the denominator in the form of, you should write in factors like this. So 2d minus d dash into 2d minus d dash. You can factorize this one like this. Otherwise, from this you can easily write 2 into d minus, but you should replace 1 by d dash. So you should be careful. So again, because square is here, so 2d minus d dash. The right hand side is 16 into log of x plus 2y. Okay, now I want to make it the coefficient of d is 1. So then only I can apply that formula. The formula is what? D minus 1 by d minus m d dash, the f of x comma y equal to integral, and okay. So you can apply the result only if the coefficient of d is 1. So for this I am taking from here, I am taking commonly 2, from here I am taking commonly 2. So 2 into 2, 4. So then d minus d dash by 2, here also d minus d dash by 2. So m is here 1 by 2, here also m is 1 by 2. 16 log of x plus 2y. Okay. So next I am going to do, I take 4 commonly here. Okay, next. So this is equal to 4 into, sorry, not 4. I think we check it. Okay, here we have 16, here we have 4. So 16 by 4 is 4. 4, and 1 by, I'll keep this term d minus d dash by 2, this term as it is. I'm going to apply only this term 1 by d minus d dash by 2. So 1 by d minus d dash by 2 into 1 by d minus d dash by 2 into log of x plus 2y. Okay, so 4 into 1 by d minus d dash by 2. So if anyone know how to apply that formula, you can tell, because I already used I saw 2 columns. So I want to check it, at least some of you know how to use this formula. So 1 by d minus d dash by 2 of log of x plus 2y. If anybody know, you can tell. Okay, otherwise I will do for this d minus d dash by 2. Next time d minus d dash by 2 is still one more factor is here. Okay, you can tell your answer for this factor. Okay, so only, okay, even I forgot the formula. Just I will write log of x plus 2 instead of y, a minus m is 1 by 2 into x. That's all. This bracket is for this one, and this bracket for this one. Okay, into dx. So this is equal to 4 into 1 by d minus d dash by 2 integral. Okay, and you should write, you should replace y by what? A minus x by 2, or a equal to y plus x by 2. Okay, so log of x plus 2a minus x into x dx. So x gets cancelled. Log 2a is constant. So 4 1 by d minus d dash by 2 integral. Okay, log 2a into dx. So this is equal to 4 into 1 by d minus d dash by 2. Log 2a is constant into x. I'll write here x. So and then you need to replace either y by, if you have y, you should replace y by a minus 2x, or if you have a minus x by 2, you can replace y by y. But here I have a, so a equal to what? Y plus x by 2. So this is equal to, the next step I am going to write, replace a by y plus x by 2. So this is equal to 4 into 1 by d minus d dash by 2 into x log 2. A is y plus x by 2. Okay, now this is equal to 4 into 1 by d minus d dash by 2 into x. So into x of log, multiply by 2, you get 2y plus x. Okay, now the time we need to apply this factor for this function. Again, this is x into log of 2y plus x. So if you know, I'll start from the integral. First, you should put the integral. So please tell the how to apply the result 1 by d minus m into d dash of f of x comma y. What about Rahul? Okay. So should apply that formula. So you'll write x, okay, x as it is, log of 2 into y. So instead of y, you should write a minus m. M is 1 by 2 into x. That's all. Plus x into dx. So you should replace y equal to a minus x by 2 or a equal to y minus x by 2. So if you replace a equal to y minus x by 2, you'll get the same function 2y. Okay. Now this is equal to 4 into integral x into log of multiply by 2, you get 2a minus x plus x into dx. So again plus x minus x gets cancelled. So 4 into integral log 2a into x dx. So this is equal to 4 into log 2a integration of x dx is x square by 2. So this is equal to 2 x square log 2a log 2a. But finally you need to replace a by y minus 2x. So this is equal to 2x square log 2 into a is y minus x by 2. So final answer is 2x square log of 2y minus x. I think a is what? A is y plus x by 2. A is y plus x by 2. So here it is 2y plus x. It's 2y plus x or x plus 2y. X plus. So this is your PA. So you know the general solution is sum of complementary function and particular integral. So the last problem number, I don't know problem number. Okay, so question, solve just give the idea to solve this problem because now the time is 10:38. So d square minus 3d dash plus 2d dash square into z is equal to 2 plus 4x into e power x plus 2y. So this is comes under which type? Type number? This comes under type 4 because exponential and polynomial here have. So auxiliary equation is m square minus 3m plus 2 equal to 0. So m minus 1 into m minus 2 equal to 0. This implies m equal to 1 and 2. The roots are distinct and hence the complementary function is phi 1 of y plus x and pi 2 of y plus 2x. Okay, now to find the pi, so the pi is a little bit you need to work out. So 1 by this is d minus, I'm factorizing like this, d minus 2 d dash and d minus d dash. From this I have d minus 2 d dash, from this I have d minus d dash. The right hand side function is what? E power x plus 2y into 2 plus 4x. Okay. So now this is equal to, should replace d by d plus 1, d plus a is 1, and d dash by d dash plus b is 2. So if you replace like this, you will get 1 by d plus 1 minus 2 into d dash by d dash plus 1, d dash plus 2. And similarly for here, d by d plus 1 and d dash by d dash plus 2. And here you write here you should write the operator e power x plus 2y. So once you operated this, you should write this here. Now hereafter I am not going to use this one. Into here just keep 2 plus 4x. Okay, this is equal to e power x plus 2y, the denominator into 1 by, I need to simplify the denominator. So d minus minus 2d dash, please check it, and 1 minus 4, 1 minus 4 is minus 3, and here d minus d dash, 1 minus 2 is minus 1 into 2 plus 4x. Okay, so again this is a algebraic function. There is a polynomial in x and y, but y is not here, so it comes under type number 3. So you should write the denominator in the form of 1 plus x or 1 minus x. I think in the previous problems I don't have the constant term, so that's why I take either d or d square term commonly. I will write the denominator in the form of 1 plus x or 1 minus x. But here I have the constant, so that's why I am taking the constant out. So if you take the constant minus 3 outside, you will write 1 minus of this term divided by 3. Similarly, I am going to write minus 1 commonly. I will write 1 minus d minus d dash. So if you take minus 3 commonly and minus 1 commonly, the next step, this is equal to e power x plus 2y 1 by minus 3, and taking commonly from the first factor, and minus 1 from the second factor. So then you can check it. 1 minus of d minus 2d dash divided by 3 into 1 minus of d minus d dash into 2 plus 4x. So this is equal to e power x plus 2y by 3. I'll write in the numerator. So 1 minus of d minus 2d dash by 3 whole power minus 1, and this one 1 minus x. So 1 minus of d minus d dash whole power minus 1 into 2 plus 4x. Okay. So this is equal to e power x plus 2y divided by 3. So 1 minus x whole power minus 1, 1 plus x d minus 2d dash by 3. I'll stop here. Don't expand more. Similarly, I'll write 1 plus x. 1 plus x is d minus d dash into 2 plus 4x. Okay. Now, here e power x plus 2y by 3. Okay. Now, I'm going to multiply by 1 into 1. So 1 plus 1 into d minus d dash. So d minus d dash plus d minus 2d dash by 3 into 1. D minus 2d dash by 3. If you multiply these two terms, I will get one more term. I don't need that term. Okay, because that term contains d minus 2d dash, d minus 2d dash. But here I don't have even y, so that's why I don't need the term. So into 2 plus 4x. So if you simplify this, e power x plus 2y divided by 3 into 1 plus, I'm taking 3 as LCM. So 3d minus 3d dash plus d minus 2d dash of 2x plus 4y. 2 plus 4x. Okay, now if you simplify, you'll get 1 plus 4d minus 5d dash by 3. So that is the next step. So this is equal to e power x plus 2y by 3, 1 plus 4d minus 5d dash by 3 of 2 plus 4x. Okay, now, so please wait 2 minutes. I will finish it, this problem, by 3. So 1 into 2 plus 4x, 2 plus 4x plus 4d by 3 of 2 plus 4x. 4 by 3 into differentiation d of 2 plus 4x. Because 5 into d dash of 2 plus 4x is 0, so that's why I don't write that one. So this is equal to e power x plus 2y by 3 into 2 plus 4x. If we differentiate this, you'll get this is 0, this is 4. So 4 into 4, 16 by 3. 16 by 3. You get e power x plus 2y by 3 into 4x plus, we take 3 is LCM, so 6 plus 16, 22 divided by 3. So if you take 3 is LCM here, you get e power x plus 2y by 12x plus 22 divided by 3 into 3, 9. Or if you want to simplify further, you can take 2 commonly. Take 2 commonly, you'll write 2 by 9 e power x plus 2y into 6x plus 11. So this is your PI. So the final answer is equal to CF plus PA. Okay. So this is end of the first unit. So before closing the session, already I send a assignment problem to you through WhatsApp. Are you willing to solve the problem? First, I will ask you. Say yes or no. Okay, if you want to try, you can try at least one set out of 3 set. At least you can try one set of questions, and the answer is also in the assignment. So try to solve at least one set, and if you have any doubt, you can ask me through group, WhatsApp group. Okay, thank you. So we'll meet on Monday first hour.